In the present lecture, we will discuss a example problem on a compound bar. Let's see the problem. A reinforced concrete column 450 mm into 450 mm has 4 steel rods of 25 mm diameter embedded in it. Find the stresses in steel and concrete when total load on the column is 1000 kilonewtons. Find also the adhesive force between the steel and concrete. Consider Young's modulus of the steel ES equal to 205 kilonewton per mm square and Young's modulus of the concrete EC equal to 13.6 kilonewton per mm square. Let's see the solution. So first to write down the given data. Here it is given the column size is 450 into 450 and this column is embedded with the 4 steel rods, each of diameter is the 25 mm. So here it is given the area of the column is 450 into 450, that is 202 500 mm square. So next we determine the area of the steel rods. So each one having the 25 mm diameter. Then the cross section of the each steel rod is the pi by 4 25 square. It is the 490.87 mm square. So each one having the cross sectional area is the 490.87. So column is consisting of the 4 steel rods. So total area of the steel rods is 4 into 490.87, that is 1963.5 mm square. So next we have to determine the area of the concrete. So area of the concrete becomes area of the column minus area of the steel rods, that is area of concrete. Let's consider AC equal to, so area of the column 202 500 minus total area of the steel rods, that is 1963.5. So area of the concrete AC equal to 202 500 minus 1963.5 equal to the, so 200 536.5 mm square. So next we have to find the stresses in steel and concrete. So when the total load of the column is 1000 kilonewtons. So here it is given the total load on the column capital P equal to 1000 kilonewtons. And also have to determine the adhesive force between steel and the concrete. And here given the ES value, Young's modulus of the steel is 205 kilonewton. So here it is the kilonewton, 205 kilonewton per mm square, and the Young's modulus of the concrete EC equal to 13.6 kilonewton per mm square. First we determine the stresses in steel and stresses in concrete. We know that while solving the compound bar problems, we are using the two relations. One is the condition of equilibrium. Second one is the equation of compactability. Let's see, the first one is condition of equilibrium. It is stated that total load on the column equal to the load on the steel rod plus load on the concrete. And we know the relationship between the load and stresses. Load equal to the stress into cross sectional area. Then load on steel rod becomes the stresses in steel rod sigma s into cross sectional area of the steel rod. So that is the AS. So load on the steel rod equal to the sigma s AS plus similarly load on the concrete will become the sigma c AC equal to total load, that is the P. So here it is given the total load P value, that is the 1000 kilonewtons. Then sigma s AS plus sigma c AC equal to, So here it is 1000. So 1000 kilonewton. So 1000 into 10 to the power 3 Newton. Let's consider this is the equation 1. And the second one is the equation of compactability, that is deformation in the steel delta S equal to the deformation in the concrete, that is the delta C. We know the relationship between the deformation and the stresses. So deformation equal to stress divided by Young's modulus. Then we can be modified. This is delta S equal to delta C equation. It will becomes the sigma S, stresses in steel, divided by ES, Young's modulus of the steel, equal to the sigma C, stresses in concrete, divided by EC, Young's modulus of the concrete. So from this one I have to stated that sigma S equal to the ES into sigma C by EC. Then sigma S equal to sigma C into ES divided by EC. So in the data it is given the ES value is the 205 kilonewton per mm square. EC value is the 13.6 kilonewton per mm square. Substitute, then equation will become the sigma S equal to the 15.074 sigma C. And let's see the first equation from the equation 1. Sigma S AS equal to sigma C AC equal to, so here it will become the 1000. So 1000 kilonewton, so 1000 into 10 to the power of 3 Newton. So here substitute sigma S equal to the 15.074 sigma C. So here I have to substitute here this value. So then it will become the sigma S is the 15.074 sigma C AS plus sigma C AC equal to, so 1000 once again here. So 1000 into 10 to the power 3 Newton. So we know AC value as well as the AS values. So substitute here. Then equation will become the 15.074 sigma C into AS value is 1963.5 plus sigma C into AC value is, so 20536.5 equal to 1000 into 10 to the power 3 newtons. So from this one sigma C equal to the, we can solve directly, we will get the sigma C value is the 4.345 Newton per mm square. So we got the sigma C value and we have the relationship between the sigma S and sigma C, that is sigma S equal to 15.074 sigma C. Then sigma S will become the 65.5 Newton per mm square. Next we determine the adhesive force between the steel and concrete. So for this one first we have to determine the average stress in the column. So average, so here it is producing the compressive stresses, then we have to consider the average compressive stress of the column is the total load applied on the column, so 1000 kilonewtons, and cross sectional area of the column is the 200 to 500. Then average compressive stress in the column equal to the, so 1000 into 10 to the power 3 divided by 200 to 500 equal to the 4.938 Newton per mm square. So this is the average compressive stress of the column. Now average load carried by the concrete equal to the average compressive stress into its cross sectional area of the concrete. So average compressive stress is the 4.938 and the cross sectional area of the concrete is the 20536.5. Then average load carried by the concrete equal to the 990.3 kilonewtons. So this is the average load carried by the concrete. But what is the actual load carried by the concrete? That is the stresses into cross sectional area. So then actual load carried by the concrete equal to the stresses. So in the concrete, that is 4.345 Newton per mm square into the cross sectional area is 536.5. Then actual load carried by the concrete equal to the 871.3 kilonewtons. Then adhesive force is the average load carried by the concrete minus actual load carried by the concrete, that is 990.3 minus 871.3 equal to the 119 kilonewtons. So adhesive force between the steel and concrete is the 119 kilonewtons. So this is the solution, and thank you.